the AI system is trying to figure out how exactly you're going to capture information about the game. So there's five main ways that we can do this. First is coding, so you can capture information in your C++ code that will allow you to use it throughout the game. The next is using data, so the most common way is data-driven design, having text files that will actually capture the information about different parameters. After that, you can use a scripting language, um, or in addition to these, you can use a scripting language whereby you can control some data about how the characters will act, what's going on in the level. You can also use rules, similar to what we went over in a previous chapter, where in the case of say like a real-time strategy game, you can have um, strategies that the virtual player could use. So you need rules to capture that information, using an inference engine to actually choose what rule you should now use, given the current state of the world. Uh, and then lastly, you can use a level editor, which can contain information about the level itself. Um, what's available to the AI, if it's at a specific spot in the level, is there metadata on the different nodes in the nodes in the map, so on and so forth. So using all five of these, you can capture information about the current AI system, and what's available to those agents within that AI system at any one time. So the third section of developing AI systems. So the first was defining the feature set. Second was designing the AI system. Once you've done those two, you need to implement the AI system. So in the case of Titanium, they wanted to leverage their familiar features from the first the prequel, sorry, the first game in the series, and so they wanted to break it out into what the low-level behaviors were and high-level behaviors were, so they could communicate with the team and figure out exactly how they would need to divvy this up among the programmers, break it out into what would need to be done by the designers, and so on and so forth. They also need to prepare a foundation for new features. So they had to figure out how they would get from the engine that they were using in their first game, and decide what they wanted to do for the second game, whether they wanted to reuse the engine, wanted to use a third-party engine, wanted to kind of use add-on third-party code for specific things, so on and so forth. What they eventually decided to do was use their existing engine, augment it with other third-party code for behaviors for systems in which there were clear, turnkey solutions. Basically didn't need to reinvent the wheel. They could just buy a product off the shelf that would be as good or not, or better than what they could have developed themselves. And once that was complete, they could start beginning working on their first iteration of the game, so the very first prototype of the game. So they tried to basically break this up into different cycles, and we'll see this in the next slide, so that they could quickly iterate and improve the game over time. So they didn't need to necessarily have all of the solutions at this point, but they needed to have kind of general ideas about what they wanted to do, and rough estimates of how long that would take, so they could make educated decisions on the direction of the game and how they were going to attack the different components that they would be creating. So the last of the four items, four phases of this, is iterate, details, and design. So you figured out what are the key components you're going to use. You've designed them out on paper. You know kind of how it's supposed to work. You've implemented them to some extent. Now you have to basically play that, determine if your implementation is correct, if your design was correct. If not, go back to the design phase, redesign, re-implement, retest, so on and so forth, until you're happy with your product, or you've run out of time. And so this is generally what I just walked through. This is referred to as iterative development. It's used on many projects in game development, and in fact, I would say almost all of them use it now. It's very uncommon for people to just get it right the first time and say, "This is our design. We've implemented it. It's done." Games are all about feedback for the player. If things don't feel right, go back and redesign, change, tweak until it is actually feels very good. And this is taken into account in all game development schedules, unless there's some unforeseen problem. Um, and so in the case of Titanium, what they decided to do was, like I said, create a prototype. So this is that first green box, so underneath initial implementation. Once they were done with their initial implementation, they had the level designers build test levels with this very simplified core feature set, so they could begin working on improving that feature set, making it as robust as possible. And so they would continue doing this until they were happy with their core implementation, and they can go into production phase. So once they've done their pre-production and they're happy with the core set of features, they can actually go in and start just building the game, and all the way through the rest of their production schedule. And from this point on, they shouldn't be making changes to that core functionality. They should be trying to work on level-specific fixes to any problems that they encounter, as this will not impact any other levels, and will ensure that any work that's done after pre-production, so in the production phase, will always run with each new upgrade or each new build that's created day after day. And so you keep using that methodology until you run out of time and you ship the game. So after going through that case study of Titanium, the book also talks about what are the careers specific to artificial intelligence in video game development companies. So there's two main roles. One is the AI programmer and one is the AI designer. So we talked about the different phases of the development. And so in those initial design phases, definition and design phases, the programmer and designer are kind of working in tandem to come up with what the requirements are. Mostly the AI designer is coming up with requirements for the features that they will need, and the AI programmer is coming up with the documentation about how they are going to achieve that. And there's back and forth here. The designer doesn't have all the control. They have to work with the programmer to come up with, a compromise, a best fit solution for what's what they're able to do given the time and what the designer would love to have. So obviously the AI programmer is going to need to know lots about code. It's standard for the programmer to have a degree in computer science. It's not absolutely necessary, but it's almost. If you have programming skills from some other way, that's great. Even if you do have a computer science degree, most game companies are going to want you to prove that you can actually do the job. So it's common for lots of programmers to have either demos or have worked on previous games or mod projects, anything that can show that they have the skills to work on a game development team. Same thing goes for AI designers. They aren't necessarily expected to have a degree in computer science. They are expected to have knowledge of games. So whether that's going to a game design program or having a degree in something related to game design, let's say literature, film, so on and so forth. I've seen AI designers with degrees that are absolutely unrelated to anything, but it's not a necessity. Oftentimes AI designers can get their start by doing demos or once again doing mods. Probably mods are more likely because of a lack of programming knowledge, and so there are teams out there that are creating games for mods of games like Half-Life. In this case, there's a picture of Gunman Chronicles, in which you're taking an existing engine, building new levels out of it, maybe changing the script slightly, adding new graphics to it. Doesn't really necessarily require a programmer. If you have a programmer, that's great because you can add new features to the game.